Welcome back to The Explainer. So today we're diving into something that is literally keeping CTOs, data scientists, and risk managers awake at night: deploying AI pipelines in enterprise finance. Look, we all know generative AI is great at writing emails or brainstorming, but what happens when you need it to pull hard, cold financial data? We're going to break down exactly what F1 scoring is and how we use it to measure AI success for production applications so you can actually trust your systems. Let's just jump right in.
So, you're moving your AI out of the sandbox and into a live production environment. Suddenly, you're staring down the barrel of the ultimate question. How do you actually know when to trust this thing? I mean, when millions of dollars, regulatory compliance, and your company's entire reputation are on the line, a gut feel just isn't going to cut it, right? You need a system that absolutely proves its own reliability. If you ask an AI to pull 100 loan amounts from a massive stack of docs, how do you know it didn't just invent 3 of them completely out of thin air?
There's this brilliant quote from some recent research on document processing pipelines that hits the nail on the head. It says, "An LLM extraction that is silently wrong is more dangerous than one that is visibly absent." Just think about that for a second. If your AI leaves a total revenue field blank, well, a human reviewer instantly sees the gap and fills it in, no big deal. But what if the AI hallucinates a number? What if it confidently spits out the completely wrong data and it just silently slides right downstream into your financial models? Yeah. That is the exact nightmare scenario we have to prevent.
So how do we stop that nightmare? We rely on a fundamental metric called precision. Imagine asking your AI to find 10 specific revenue numbers in a massive document. If it hands you 10 numbers, but 2 of them are just completely made up, your precision is shot. High precision basically means when the AI says a number exists, it's not hallucinating, it is actually there. Think of precision as your incredibly strict quality control inspector. It's measuring the AI's ability to avoid making things up, eliminating what data scientists call false positives. If the AI says it's there, you can take it to the bank.
But, okay, here's the catch. A quality control inspector who rejects absolutely everything doesn't actually help you get any real work done. And that is where our second metric comes into play: recall. Let's go back to our example. Imagine there are actually 20 revenue numbers hidden in that document, but your AI only found 10. Well, that's a recall failure. Recall is essentially your net. It measures if you caught everything or if critical data just slipped right through the cracks. High recall means zero missed data. You're stopping those false negatives and grabbing every vital piece of information. And this dynamic sets up a really dangerous trap that every single AI production team faces. It's a massive balancing act. If you make the AI too strict, like hyper-focused entirely on precision, it's going to play it so safe that it actually misses valid data. But on the flip side, if you make it too eager and tell it to catch absolutely everything just to boost your recall, it's inevitably going to start hallucinating and grabbing totally wrong numbers. It's this constant tug of war, really, fighting hallucinations on one end and fighting missed data on the other.
So how do we actually measure our success on this tightrope? We use the number 1.0, which is basically 100%. In the machine learning space, 1.0 is what a mathematically perfect AI score looks like. It is the absolute holy grail. It means the AI found exactly what you asked for, literally nothing more, nothing less. Zero missed data, zero hallucinations. But, the real question is, how do we calculate our progress toward that perfect score?
Well, we need a single metric that tracks our progress toward that perfect 1.0 by combining both precision and recall. Enter the F1 score. You can think of the F1 score as the single final grade for your AI. It acts as the mathematical peacemaker between those two competing forces we just talked about, and crucially, it strictly punishes an AI that is terrible at either one. If your AI is hallucinating wildly or missing half the document, that F1 score is going to tank. It gives you one undeniable number that proves exactly how trustworthy your AI truly is.
But here's the thing. You can't calculate an F1 score in a vacuum, right? You can't grade a test without an answer key, and that is your golden data set. It's a locked-down, version-controlled vault of manually verified, absolutely perfect AI outputs. Whenever your engineering team wants to update the AI model, they have to run it against this golden data set first. Testing against this vault gives us the mathematical proof we need that a new AI model won't regress or break our production system. Now, what's really cool is how this F1 score actually transforms from just a measurement into a completely automated gatekeeper for deployment. Because let's face it, not all data is created equal. For a critical tier 1 field, think total debt or EBITDA, we might set a super strict F1 target of 0.98. If the AI dips below that, boom, the system triggers a hard block. The pipeline halts entirely. But for standard tier 2 fields, like operating expenses, a score of 0.90 might just trigger a warning. This is exactly how you enforce rigorous risk-based governance right in your code. Okay, we need to make a really important pivot here, though. That historical F1 score, it's fantastic for protecting our pipeline updates when we already have the golden data set to check against. But what happens when a brand new live document hits your system? You obviously don't have the ground truth for it yet. That means for live documents, we still need real-time confidence scores generated on the fly by the API to tell us just how certain the model is in that exact split-second moment.
To handle this, we set up a really slick real-time production flow. It goes like this. Step 1. Extract the data from the live document. Step 2. Instantly check the model's historical F1 track record for that specific field to see how reliable the AI usually is. Step 3. Rapidly calculate the real-time API confidence to gauge how sure the model is right now. And finally, Step 4. Automatically route the document based on those numbers. Basically, the system either instantly approves it or it raises a flag and demands a human step in.
When you combine these two metrics, you build this brilliant confidence matrix that completely redesigns your team's workflow. It literally shifts your team from painfully reading every single document to only managing the exceptions. If historical F1 and real-time confidence are both high, green light, auto-approve. But think about the absolute worst-case scenario. If the AI has a historically low F1 for a field and is showing low confidence right now, the system flashes a critical red, making human review absolutely mandatory. It directs your human experts exactly where their attention is actually needed most.
Now, to ensure this whole system doesn't just quietly degrade over time, we use a blind review queue. Think of it as a continuous safety net. We actually take 5% of all live production data and invisibly route it to human reviewers who extract the data from scratch. Then, the system compares the AI's live output against this new human ground truth to calculate a continuous production F1 score. If the model starts to drift, and they always do eventually, this mechanism catches it immediately.
And that brings us to the ultimate question for anyone building with large language models today. Are you treating your AI like a black box where you just kind of cross your fingers and hope it's right? Or are you actually managing it like a fully auditable microservice? By using F1 scoring, golden data sets, and real-time confidence matrices, you can absolutely bring regulatory governance and unshakable trust to your AI deployments. Thank you so much for joining me on this explainer. I really hope this sparks some ideas on how you can bring rigorous trust to your own AI pipelines.